All right, welcome back. So I hope you had a chance to take a short break. So let's share the screen and see what's happening here. So apparently, and as you see here, the message written in the command window out of memory. And that's something not uncommon in the calculations. Sometimes you need to store gigantic arrays, and these arrays are simply cannot fit in the RAM memory of the computer. So guys, we are not talking here about the hard disk. So the hard disk is where you write final data to, let's say, a text file. And that hard disk is typically large, right? So for example, this machine that I'm working on, it has like a half a tera or a terabyte of hard disk. But when it comes to RAM memory, RAM is extremely expensive compared to hard disks. And I would say that this computer, I think it has like 16 gigabyte RAM memory. And obviously the arrays I inserted are gigantic here. So I try to exaggerate. So the exercise is asking you for 100 million, but I tried to exaggerate and make it 1,000 million. And that was crazy because it make it to run out of memory. And you can do the simple pen and paper calculation estimating why this runs out of memory. So million is mega, and thousand million is basically 1 giga, right? So each array is 1 giga, but 1 giga what? Giga number. And each number takes in the memory of the computer about 64 byte. So that's literally means that the X itself is gonna be 64 gigabyte, right? And that thing is gonna be, you know, another 64 gigabyte, and tentatively, of course, these are estimates. So I'm way, way, way above the RAM memory of my computer. That's why it's not gonna run, right? But of course, when we did the exercise before the break with reducing 1 0 from here and 1 0 from here, 1 0 from here, we actually learned the message of the exercise. The message of the exercise is the following. Whenever in MATLAB, whenever you can do something with an array or a matrix and avoid a for loop, then please do it this way, because usually this is faster. You remember it took 5 seconds, while with the for loop it took like 10 seconds, so double the time. So don't underestimate this if you are doing a big calculation. So any question on for loops before we discuss while loops? Just unmute yourself and ask if something is unclear. Perfect. It seems we are doing well. So I'm gonna go to the whiteboard and move this here to the left. Basically, I'm gonna discuss the syntax of the while loop, and I hope you can see my whiteboard here. If there is an issue in seeing it, just please let me know. I can fix this. So the next thing is while loop. And as we said, it's counter controlled. While loop can be actually, the standard way to write a while loop is as follows, is to say while, and then there is some condition that you write here. And as long as the condition is satisfied, the loop keeps running, calculating stuff, and then there is an end statement. Okay, so that's really the standard way of writing a while loop. However, there is another format of while loop that could be useful in certain situations, and that's why I will also introduce it, maybe right here beneath this one. And the other format is as follows. It says while one, and this looks odd, like what on earth while one means. It basically means one in MATLAB, one means always true. It actually means true. Like, so while it's always true and it's gonna be always true, this loop is gonna run. until an end statement. Obviously, this is an infinite loop because it never stops. Then when do you put the breakage condition, the condition that stops the loop? Using an if statement in the middle of the loop. For example, you say, if some condition is satisfied, okay, then you break the loop, break the while loop, and you put an end statement for the if. You might wonder, what is the advantage of this one, or when this one or this format could be preferred over the other one? It could be preferred if the condition is going to appear in the middle of the loop. While here, if your condition can appear at the beginning of the loop, then you can put it just right next to while here. So that's the only difference. Where do you put the condition? So sometimes the condition appears next to the while, okay? And sometimes you want to put it inside the loop, so you put it inside, and when it's satisfied, the loop is going to be broken. You'll actually take one example, and we will try to solve it using both ways, like both formats. I have to say, one could, in my opinion, what could write any for loop in the first format using the second format and the vice versa. You can really play around and use this one and this one. Okay, let's take an exercise just to illustrate this idea. Again, we will take it from our drive here. So this one, oops, let's get it back. So we are gonna do question number 4. But as I said, we will do it 2 methods. One time using the first format of while, and the other time using the other format. So it says the Fibonacci sequence of integers is such that each term is the sum of the previous 2 terms. And the first 2 are 1 and 1. As such, the first few terms are as follows. Let me explain this maybe on a whiteboard here. So the Fibonacci sequence, and this is a very interesting sequence because it appears in nature in very, very frequent events. So for example, if you just open a new tab and type Fibonacci sequence, and you type images, you will find many, many interesting things in nature, like some plants, some seashells. The growth of the seashell, how the volume is changing, is following a Fibonacci sequence. So it's very interesting sequence, and I strongly recommend you to read something about it. But how do you generate the numbers of the sequence? That's the thing that we are going to use in this exercise. So the first 2 terms of the Fibonacci sequence are 1 and 1. So that's the first term, and that's the second term. And it says that each new term is the sum of the previous 2. So if I want the third term, it's going to be 1 plus 1, which is 2. If I want the fourth term, it's going to be 2 plus 1, which is 3. If I want the next term, it's going to be 3 plus 2, which is 5. And then I keep going. Next term, 8. Next term, 8 plus 5, 13. Next term, 21, and so on and so forth. So we are asked, if we go back to the exercise, we are asked to calculate the Fibonacci terms whose values are less than 1,000. So which is basically 1 and 1 and 2 and 3 and 5 and 8 and 13, all the way to the last term right before 1,000. Okay, so obviously you need some sort of looping, right? Because you keep calculating terms, so you need some sort of looping, but you don't know beforehand how many terms you need to calculate, right? Because I don't have a clear, like, I don't know if there are 20 terms whose value is less than 1,000. That's why this needs to end with an if statement. Okay, let's try to work this out together. And again, if you have MATLAB open, you can try to work out this exercise with me. So I'm gonna save this. Let me call it Fibo like Fibonacci. So this code calculates Fibonacci sequence terms whose values are less than 1,000. Okay. All right. So what do we know? We know the value of the first term and the value of the second. That's all what I know so far. Just the first term and the second term. So I know F1 equals 1, and I know F2 equals, 1. Okay. And obviously, I need to loop and calculate each term, but then the loop has to end with an end statement. Okay. So what am I going to calculate? I'm just thinking out loud. So I really don't have a clear idea yet. I'm just to try to think, and so I might fail, so I might need to modify. We will work this out together. So I'm going to calculate maybe new f. The new f is f1 plus f2. So that's the new term. So if f1 is 1 and f2 is 1, then the new f is 2. But then I need to, to display something to display to the user the values of the f's. So maybe I should start from displaying the first term. So let me actually display the first term, which is f1. So I displayed f1. I calculated the new f. And now I need to shift. Shift means what? So I'm gonna, whatever was f2 is gonna be the new f1. So the new f1 is f2, and the new f2 is gonna be new f. Okay. And let me explain this. What am I trying to do? So let's follow the loop. I started with f1 equals 1. And then f2 also equals 1. And then when I enter the loop, I'm going to calculate new f. New f is going to be f1 plus f2, which is basically 2. But then I'm going to shift the values. So I'm going to erase from the memory the old value of f1, and the new value of f1 is going to be f2, but it's also still 1. Similarly, I'm going to erase from the memory the old value of f2. I'm going to store instead of it new f. So now f2 is 2. Then the loop runs again. When it runs again, it's going to display this, which is 1. Okay, and that's fine. And then it's going to calculate new f. New f is basically f1 plus f2, which is basically 3. That's the next term in Fibonacci sequence. Then I'm going to shift the values. The new f1 is going to be the old f2, which is 2. And the new f2 is going to be new f. So the new f2 is going to be 3. And so on. You see, I'm progressively storing the values of the Fibonacci terms inside f1. So I can actually focus my attention on f1 because it starts as 1, and then it becomes 1, and those are the first 2 terms of Fibonacci sequence, and then it becomes 2, and then it will become 3, and then it will become 5. So I can actually focus my attention on f1, and I can make the while based on f1. In fact, I'm gonna put here the condition while f1 is less than 1,000. Please keep doing this. Then what happens if f1 exceeds 1,000? Then it's gonna stop. That's the breakage condition. Okay, so let's try to run this code and see what's gonna happen. I should put a CLC and clear all to erase whatever was in the memory. Run this. So let's see what's printed out here. So MATLAB printed 1 and 1. These are the first 2 terms, and then 2, and then 3, and then 5, and then 8, and then 13, 21, all the way to 987. 987 is the last Fibonacci term before 1,000. The next term is going to be more than 1,000 because it's going to be 987 plus 610, and that's obviously a number greater than 1,000. So guys, is this clear what's happening here? Any question? Let's look at the participants. Just unmute yourself if you have any question on this. Very good, no question. So this is, I'm gonna bring back the, and maybe should I clear the window here? I'm gonna bring back the whiteboard. So guys, I said there are two ways to make your while. Either your condition appears next to the while, or the condition has to appear in the middle. Let's try to write the same code, but with the condition appearing in the middle. In fact, let me take this, I'm gonna copy it. I'm gonna open a new script. I will paste this. I will save it as, let's call it Fibo 2. So the second way of writing a Fibonacci sequence, Fibo 2. So what's the difference now? I don't want to have the condition here. In fact, I'm gonna put 1 here, while 1. Guys, if I run this, MATLAB will run forever, really forever. So I should have a break statement, right? And the break statement is based on F1, okay? So let me put the break statement right after the display. So if, every if has to come with an N, okay? This is the breakage condition. So I should state what is the condition that's, if satisfied, it's gonna break. So if 1 is greater than 1,000, then please break this while loop. If 1 is greater than 1,000, then please break this while loop, okay? So notice the difference. This is a breakage condition. So break when F1 is greater than 1,000. Here, it was a continuity condition. So keep running as long as F1 is less than 1,000. So what happens if F1 is greater than 1,000, then you stop, okay? So in a sense, those two are equivalent. But here I'm using the breakage condition inside the while loop. As I said, it's like an extra flexibility where to put your while loop, your break statement. You want to have it in the form of a continuity condition on the top, or do you want to put it somewhere in the middle of the while loop? In fact, let's run this, make sure that it's running. I'm gonna hit run. Okay, that's actually doing something strange. It's printing an extra term. You see, it's, so if you notice, it printed an extra term. So why this is happening? So apparently it's happening because of the position of the F statement that breaks. Because apparently what happened is, so after the code calculated 987, it actually, even after calculated 1597, it looped one more time, displayed the 1597, and then it broke. Well, if I want to force it to only display 987, which is the previous term, and think about it quickly, what should be the solution? Any suggestions? The solution should be easy. Just put the break statement before the display. This way, it's gonna break before it displays the 1597. Let's actually test this and make sure that it's running. Run. Now it works well. Now it worked well because now it prints 987 as the last number because it breaks before they display the value of F1. And now really this one is very similar to this one. Okay, any question, guys, on the while loops?
We have a question from the shadowing link.
Yes, please go ahead.
He's asking what happens if we place line 13 and 14. I think before we changed the order. يعني he means now 14 and 15. Yeah. What if we replace them?
Replace them with the F statement, right? Probably.
No, he means line 14 and line 15. What if we replace them together? يعني if we bring 15 up and 14 down.
Like this. Is that if it is what if this what is meant, nothing really happens. I mean,
No,
if
if
that's
we
all.
bring بقى F1 equals F2 below it.
Oh, here at the bottom,
No,
below, underneath them. So let me
no,
cut.
I mean just the statement F1 equals F2 gets below the statement F2 equals new F.
Oh, oh, I see. I see. No, 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 no. Please don't do this. Thank you very much. This is an important question. Thanks a lot. Thanks a lot. So, so let me reiterate the question. One of the colleagues is saying, hey, suppose, and let me do it here. Suppose I actually put this one here. No, that's not good. Because in this way, I'm storing in F1 and F2 exactly the same number, which is the so-called new F. No, 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 I don't want this. This is gonna be completely wrong. Guys, how this is gonna run? So let's actually track this. I'm starting with F1 equals 1. I'm starting with F2 equals 1 also. So F2 also equals 1. So let's follow that. Whenever you have a question of these things, try to do a couple of calculations with a pen and paper. So it's going to display F1, which is okay. And there is no breakage because obviously I'm not exceeding 1,000. Let's calculate new F. So new F is going to be the sum of these two guys, which is 2. And then F2 equals new F. So F2 equals 2. And F1 also equals F2. But F2 now became 2. So that means that F1 is also 2. This is very problematic. I'm calculating something wrong. Because when the loop loops one more time, it's going to calculate new F. So new F, then new F is going to be 2 plus 2, which is 4. Completely wrong now. I'm completely wrong. And the next F2 is going to be 4. And the next F1 is going to be also 4. So the next number is going to be 8, right? And that's completely something different than Fibonacci sequence. So this little change of order by basically putting F1 equals F2 after F2 equal new F is completely messing up the sequence. That's why I need to bring it back here, be able to calculate the correct Fibonacci sequence. I hope this clarifies the point that was raised in the shadow meeting room. Any other question, guys? If you have some question, just please unmute yourself, or hopefully the ASME students can help us if there's another question from the shadow room. Perfect. It seems we are doing well. Great. So now we want to go to the breakout rooms to do one more exercise on our own. In fact, it's not a new exercise. Let me bring it again from here and put it on the screen. Exercise number 6, I will leave it to you as an entertaining exercise that can be solved at leisure during next week. And if you have questions, we can discuss it after the session. While what we want to do now in breakout rooms, in fact, it's the same exercise that we solve it with a for loop, but now we want to do it with a while loop. It says, given this series that sums to pi over 4 over 90, approximate the infinite series by a finite one that ensures that the relative percent to true error is less than 10 minus 7%, right? In the previous example, it was asking you to calculate a finite series up to 100 terms. So it was an obvious for loop. Here, I'm telling you, hey, keep calculating, but stop the calculation when the percent true error goes to below 10 minus 7%. Once it becomes less than this number, stop here. Because of this, I don't know how many cycles do I need, right? And because of this, I have to use a while loop. Similar to the previous case, we are asking you to plot the relative percent error as a function of the number of terms. But again, I don't know how many terms. In the previous case, I knew there were 100 terms. Here, I really don't know. Similarly, make the y-axis as a log scale and the x-axis as a linear scale. Look, just for the purpose to help in making this example smooth, I'm gonna upload on the shared folder the exercise that we just solved with the for loop. So in fact, I will put all of them after the session, but let's do this. I'm just gonna copy here the finite sum, the one that we did with the for loop. That can speed up you coding the new exercise with a while loop. So now it's uploaded on the shared folder. So guys, please, let's stop the recording here, go to the breakout rooms, and I will give you maybe